Hello, it's Mike here, and welcome to the incredibly misleading Allegro game library tutorial series. That's because, actually, it's going to be just this video. So I did the Getting Started one earlier, a couple weeks ago, and then I put together the entire series on the Game From Scratch website in text form, which I will link down below. And I realized, you know what, I could probably do this in a single video as opposed to a series of videos. So that's exactly what we're going to do. Basically, we're going to walk through the basics of using the Allegro game library. Now, if you've never heard of it or you didn't watch the Getting Started tutorial, Allegro is basically a low-level media framework. It's a C++ library for doing all that low-level hardware stuff. Things like handling your controllers, creating a window, handling input, handling graphics, sprite drawing, graphic loading, font rendering, etc. So this low-level stuff you need to make a 2D game, Allegro handles it for you. And without further ado, let's jump right in. Now, if I'm not giving you quite enough backstory, do be sure to watch the Getting Started video. I will also link that down below. And don't worry too much if you can't keep up with the coding. All of the source code is available on Game From Scratch. Simply head on over to GameFromScratch.com and you will find any of the Allegro tutorials. Click the table of contents. I'll add this to the tutorials link as well, so it'll be available there. But you'll see this is basically what we're going to cover. First off, Getting Started, which we've already basically done. A simple game loop. Then we're going to look at drawing sprites or bitmaps, handling the keyboard and mouse, handling audio, and then finally some graphics primitives works, and then we're basically done. Now, for this entire thing, I'm going to be using Visual Studio 2017, and without further ado, let's get started. Go on in, create a new project. Obviously, this is a C++ project. I'm going to be creating it as a Windows console application. We will put this in my temp folder. We will dub the Allegro. All right, we are good to go. All right, so now that we've got the project created, one of the first things we need to do is actually add the Allegro dependencies. Just come on up here, click your references, click Manage NuGet Packages, go over here to Browse, and then search for Allegro. This is why using Visual Studio in this case is very nice. It makes the setup incredibly easy. So go ahead and add the dependencies that we need. This is going to take a few seconds, but it's nothing too big. All right, and we're also going to need to set up a folder for us. So let's go ahead over here and say open in Explorer. All right, so we got our debug folder. You know what, that works for me. All right, so we'll make sure that's our run directory. So head on back over Visual Studio, grab your project, properties, and what we want to do is make sure that our debugging directories are set so when we look for files, we know where they are. So just come up here, working directory, we'll browse, and we'll make sure it's that debug folder. That means that that's where we need to locate all of the files or assets we're going to use. Okay, so that is set. Now it's time to get down to some coding. Very first thing we're going to do, very simple, is we are going to just create a window. So it's nice if you can type, pound include Allegro header file, like so. And we'll use standard AFX.h just because it's set up for precompiled headers, so I'll leave that in so we don't have to do any more setup work, but that's not important in your case. And now, first thing we need to do is create a pointer for our display variable, and we will dub the display. And you'll notice this over and over again when we're dealing with Allegro libraries. There's a lot of initialization and destruction calls, especially when we start getting into some of the add-ons, as we'll see in a moment. Basically, we're just going to tell the library to initialize itself. You'll notice this naming convention is very consistent. Allegro calls start with AL underscore. And let's go ahead and create our display. And the resolution we wish to create our display at is 640 by 480. Now we're just going to do a quick bool. And our simple, quite horrible game loop, don't worry, we'll make this better in a second. So while our game is running, we just want to say AL flip display. Now this is kind of an old-fashioned term. You don't see it too often in game programming these days. But what happens here is you're basically drawing to an off-screen buffer, something called a back buffer. And then what you're doing here is saying, display this to the front buffer or the video card. Again, it's an old-fashioned terminology, but what you're doing is you're working in a memory buffer and then copying it to the display. So you could also think of AL flip display as just draw the screen. At this point in time, there's not really a whole lot going on since, well, first off, We can never actually exit this code. This is an infinite loop that will run forever, but I'm going to show you how to make that a little bit nicer in our next example. So now that we're done here, we're just going to do some cleanup. So this is a pointer. We allocated a pointer. This is allocating a pointer for us. It's declaring memory, etc. So basically, anytime you have one of these things, anytime that you're populating a pointer variable, there's probably going to be a corresponding destroy call for it. And this will clean up the memory. So when you're done using whatever that thing is, go ahead and call destroy to get rid of it. And there's our example. It's not going to be that impressive. Oh, it's not going to be impressive at all. All right, so just moving the standard AFX call to the top, so our header file is properly included. We'll go ahead and do the build. Our build works properly. Go ahead and run it. And as you can see, we have a 640 by 480 window shown here. Nothing too exciting, but you'll also notice there's a console window in the background. That's because we loaded this guy as a console app. I will show you how to get away with both those things. Now, unfortunately, the only way to exit it is to actually kill it in the debugger right now. We'll get onto that in a second. So if you want to change that behavior out so that console window is not created, go on into your properties of your project. Go into, I believe it's linker, system, and change console here to Windows, like so. And now when you run your code, you will no longer get that console app in the background. All right, so that is probably the simplest and possibly most useless Allegro project you could ever create. Let's take it one step further and make that game loop a little bit better. So we're probably going to want to be able to, exit it. And in order to do this, we're also going to need to start handling some events. So that's the next thing we're going to add on here. So below our display here, now what we need to do is create something called an Allegro event queue. This guy, again, it's a pointer. We'll give it the incredible name of Q. And now we're getting into where we need to start adding some of the modular aspects of Allegro. Now, the cool thing about the Allegro library is it's pay for what you use. So if you don't need functionality, it's not included. It keeps the binary sizes down, etc. But as you need things, you have to initialize them. And in this particular case, we're actually going to need access to the keyboard. So what we need to do is come up here and go al_init, and we change this guy to install keyboard. So this installs the keyboard functionality and makes it available for us. Okay, I'm varying from my example code a bit, so I'm going to go back to the right order I should be doing things. So let's cut this guy down here. We'll move it down a little bit. So after we create our display, what we need to do is create that queue. Very simple. You're going to probably be able to guess what the functionality is. Is create event queue, like so. And the event queue is basically where all of our events are going to, well, queue. I guess I could have maybe saved myself from saying that, but this is where all events will come in. And you can have multiple events, as we're going to see in a second, all kind of come into the same queue. So there is our keyboard installed and ready to go. Now, we're going to tell it that we actually want some events to go to the queue we just created. And that is a matter of calling al_register_event_source. And we're going to do it 2 times. The first one's they're all going to the queue. So this is the destination where this event should go. And I should probably spell that correctly. Like so. And we want al_get_keyboard event source. So basically we want to get events that come from the keyboard, and we also want to get events that come from the display. That's way we can handle resize, or in this particular case, the close event. So in this case, we're going to go al_register_event_source. Okay, there we go. Finally spelling. And again, we're reusing the same queue. You could create multiple queues if you so wished. And then we're going to go al_get display event source, but you could have guessed that one. So this is going to handle, the first one handles all the events that come in from the keyboard when you press a key, release a key, etc. This one handles all the events that come in from the display. And we need to pass it a parameter of which display. So this is the pointer we created earlier on. All right, so now we can make our loop a little bit less useless here. So we've got our flip display. We want to keep things as they are, but now we want to actually pull for the events. So we're going to create an Allegro event object called event, al wait for event in that queue. And we pass in a reference to our event. That's where the event will be stored once it happens. So basically, this is going to just basically wait for something to happen. And then we check what actually happened once that event comes in. So event.type equals Allegro underscore event underscore key up, or event.type equals Allegro underscore event underscore display close. So if they close the display or they hit any key, we will exit our loop. Oh, actually, that doesn't make any sense. Running equals false. So what this does basically is turns this switch off, so then our loop ends. And now we will get down to our cleanup code down here. Now you'll notice we've got our destroy display call. We're also going to now uninstall the keyboard. Now, you may be thinking to yourself, well, you're about to exit your application. Do you really need to do either of these? Well, no, not really, but it's a good practice to get into so that you're always cleaning up after yourself, and you've learned when, otherwise you will link memory if you're not exiting the program at this point in time. All right, so that's second example. Let's go ahead and run this guy. Builder. And there you go, exact same thing as before. The biggest difference is now we don't have to use these guys. We can press any key on the keyboard, or we can click X in the corner, and it will now exit out. So our game loop is a little bit tighter now. Now, one of the things you might want to get into sometimes is you might want to run at a fixed hertz or a fixed rate in your game loop. So if you say you want your game loop to run at 60 frames per second, for example, well, this can also be done using event queues. In this particular case, you could do it using a timer. So now let's look at that example. So I'm just going to modify this example just slightly. So we come up here, so Allegro underscore timer. So another pointer, this time it is a timer. So we have our queue that we created here. Now below that, we are going to create a timer. Equals al create timer. So you can see there's very consistency to the naming convention here. Now we got to tell it how frequent to call. So we want it to call 60 times a second. So we'll just do the math that way. So this timer will call every 0.22 milliseconds or whatever that math turns out to be. And we need to do down here, register one more event source. Exactly like all the other event sources, except for this one is a timer source. So our queue there, al get timer event source, pass in your timer. Like so. So now this event will be created every time the timer ticks, basically. And now we can change up our queue slightly. So exact same thing, just down below here. What we're going to do is we're not going to draw it every frame like we did before. Instead, we're only going to draw it every time 1/60th of a second has elapsed. So we're going to go down here and go if event.type equals Allegro event timer, so that means our timer ticked. Then al flip display. There you go. And again, exact same result. Nothing too exciting to look at yet, but we're getting there. We're getting slightly more into exciting land in a second, because we are now going to move on to dealing with graphics. Now, first thing I need to do is actually get some kind of a sprite to deal with. Let me just grab that guy. So what I'm using here is these assets. I'll just grab them all for now. So you see we're using this PNG file, or this little PNG file eventually. So we're just going to go ahead and drop those into our debug folder, which is where we set as the working directory. And if you get an error going forward, it probably means that one of these files was not found and you didn't set the debugger working directory right in the debug section. So if you do, when you actually run this example, get some kind of an exception, it's most likely because it can't locate the resources. So there was either a typo in your file name or you didn't set the working directory correct. That's an error that is as old as the world itself. All right, so now we're moving on to actually drawing that graphic on screen. This is where the exciting stuff, I guess, starts to happen. We'll actually start seeing some end result. And in this particular case, it will build on the same code. So Allegro underscore bitmap. All sprites and bitmaps are pretty much interchangeably used. We'll call it bitmap, like so, and we'll start it off null, like so. Okay. Oh, I think I forgot to close my timer off. Oops. As I said, get in best practices. So that was from the last example. That was a mistake on my behalf. Okay, so we just allocated our new bitmap. And we're going to actually need to go ahead and start using our add-ons for the first time. Now, if you saw the very first tutorial I did, basically the Hello World one, we already went through this process, but don't worry, it's very simple. So these are extensions to Allegro, and almost half of, or 3/4 of the functionality in Allegro is implemented as extensions. Again, it's just the pay for what you use kind of aspect of it. But all you do is come down here and go to Properties for Allegro, and you'll see there is an Allegro 5 section available right here. And this is where you extend the functionality that you need. And what we need right now is the image add-on to be enabled. And we need the... Oh, no, that's all we need. So this will give us the functionality to be able to load PNG files or JPEG. Okay, what did I actually copy in? JPEG. All right, so this gives us the ability to load the image files we need. Now, it supports the common ones, JPEG, PNG, I think GIF, but I'm not 100% on that. Okay, so now we need to go ahead and create our bitmaps. We'll do this after all of our event sources. So now we need to do another init call. This is image add-on. And this is the kind of functionality you use for implementing all of the add-ons. It's a very consistent approach they take. Init image add-on. I'm getting a lot of squiggly lines, so I'm not sure why it doesn't. Oh yeah. Also, the add-ons are implemented as separate header files. So pound include Allegro 5/image Allegro image. That should get rid of our squiggly line. All right, good. So you have to initialize all the add-ons. The functionality is exactly the same. You have al_init call, and at the same time you have to get rid of them. I believe. No. Okay, this part is kind of inconsistent with the library. So in this case, we just initialize it and we are good to go. So now that the library is initialized, we can go ahead and load our bitmap. So bitmap equals al load bitmap. Now keep in mind, this is a pointer that is being created for us. So you're responsible for getting rid of it at a later date. We can go ahead and jump to that later date right now. And it's got, you get rid of something using, again, just like the timer up there, destroy bitmap, and you pass in the bitmap to get rid of. All right, so we loaded the bitmap from file. Obviously, the directory is relative to that working directory we defined earlier on. Now, I'm gonna be a bit lazy here. Let's do an assert to make sure that the bitmap is not still null. If it is, actually, do it the right way. That will throw up in your face, basically saying it will stop execution at this point exactly. Sorry, I got a bit distracted there. So we want to make sure that our bitmap actually loaded correctly. If it didn't, this assert will fail, and you'll get thrown up an error message basically saying that bitmap was not equal to null. In an actual game, you would probably want to handle things a bit more elegantly than just crashing out. But in this particular case, it works just fine for us. We're going to need another local variable here too. And that's just for our x value. We're going to show some very primitive animation in this example. And now we're going back down here to our draw code, so our flip display right here. We're going to change this out slightly. So we're going to draw a background color, clear to color. Colors are represented here as an RGB map, which are called a AL map RGB a floating point 1 1 1 1. So basically, let's make our background white. Wait, full color, yeah, white. And finally, we draw our bitmap. We'll move the X value slightly every frame. And then this will actually cause the code to be displayed. Now the order here is important, otherwise updates will not be shown until the next or the subsequent frame. And we'll do a quick check here. If x greater than width, where did I get width from? Yeah, my bad. I didn't actually declare this variable yet. Okay, why is my equals key minusing? All right, so we also want the width of the display. Easy to get. Width equals al get display width. And of course, you got to pass in which display. Like so. So come back down here. Basically, if width x is greater than the width of our display, x equals al get bitmap width bitmap. So what we're basically doing here is if we go off the right hand side of the screen, we're going to want to go to the left hand side of the screen, but we want to go relative to the position of our bitmap. So we want it to scroll back onto the screen instead of just being fully drawn. So we're going relative to the left hand corner. Now this is an important point to raise because this is the coordinate system being used, and I'll show this when we actually run our example. There were errors. Damn you. All right. What did I... Stop. Go away. What did I miss here? I missed a 0. No flags. All right. Let's do that again. You can send in some draw flags, such as to flip it or otherwise. Okay, now I made a bit of an idiot move here, and it was actually in the last example. And let me just quickly explain what it is. So what we've done here is we basically made our event loop or our game loop event driven. So we're only going to update and draw the display every time our timer ticks. So up here we created a timer that is going to call it every 60th of a second, which is a great idea, except we never actually started the timer. So it never fired, which is, you know, perhaps maybe a minor mistake here. So what we want to actually do here is just call al start timer and pass in our timer. Now, speaking of mistakes, I actually have already finished recording this video, and then I realized I actually paused and unpaused at the inappropriate time, so I am filling in a midsection that I missed out. So if things seem a little jarring right now and in a couple of minutes, that is why. But don't worry, it'll all make sense in the end, I hope. So this is why things didn't work right. So basically, for this event loop to be called correctly, our timer actually needs to be running. So we'll go ahead and we'll run this. Hopefully I have rewound the code to the right point in time. All right, where's my errors? It's all right. My library is currently in the wrong state of add-ons. So I need the image add-on as a yes. Audio, well, I'm gonna need it eventually. I'll just leave it on. So go ahead and run that. And there you go. You see we are slowly advancing off the one-hand side of the screen, like so. Now you might want to jack this number up a bit to make things a bit more exciting. And run that out. And you see it scrolls off the side and comes back in on the other side. A couple valuable things, hoping I haven't already pointed this out. Drawing is all done to the relative top left-hand corner of the drawing surface and to the top left corner of the bitmap. So important to realize, and that's why we do this here, so that when we start it to the left-hand side, it takes account, you know, its drawing point is relative to its far left, so we have to minus out the width. Okay, so that is it for sprite drawing. Pretty straightforward. Now we're going to switch it out to input handling. Now, one of the things I need to do right away is have a smaller image to work with. So basically, this is going to be like a mouse cursor. Now, when I drop these things in, I dropped in 2 versions. There's image 64 by 64, which is a smaller version of the Game from Scratch logo. And now let's jump back over and continue. So what we're going to do now is handle mouse and keyboard. Now, we've already dealt with the mouse a bit. So, sorry, we already dealt with the keyboard a bit. So instead, we're going to look at polling. Eventually, earlier we did event-driven. So basically, if you press the key on the keyboard, blah would happen. Now, this works great unless you start getting into wanting to handle multiple keys at the same time. So what we're going to do in this example is instead of just exiting out when you press any key, we're going to poll the state of the keyboard. We're also going to handle the mouse. We're going to move that icon around relative to where the mouse is located. So instead of just needing X, we're also going to need Y. And we'll set those both out to 0 to start, like so. And as you probably can guess, you need to use, so we had to install the keyboard. Well, we also need to install the mouse, like so. And we also need to add it as an event source. So you can probably guess exactly how this code is going to look. al get mouse event source, like so. So now we are getting mouse events and keyboard events, and we are off to the races. Now let's go down to our loop, and we'll change things out quite a bit here. First off, we don't really need the key code here. So basically now we're going to change it so clicking the close arrow exits things out. Otherwise our new code is going to go here. So let's first handle mouse. So mouse is done pretty cleanly, pretty easily. We're just going to do, so we've checked for events, so we've waited for our event up here. Wait for event, so here we go. If event.type equals Allegro underscore mouse underscore axis. Okay, so basically if the mouse has moved, handle it here, and we're going to do pretty straightforward. We're going to set that local x value to the value passed in the event structure, mouse x, and we'll do y equals event dot use mouse dot y, like so. And this should already work, so we'll go ahead and run that out. And now you will find, oh, we need to get rid of that code. All right, let's get rid of that. So we're going to draw the bitmap at x and y instead of moving it all the time. And now go ahead and run that, and you will see the mouse, the icon draws wherever our mouse is currently located. Very cool, very simple. So handling mouse events was quite simple. Now let's look at handling a mouse button. And what we're just going to do is, if you press the mouse button, we're going to reset back to the 0, 0 location. So Allegro event mouse button up. So that's when the button is released. We're going to go x equals y equals 0. So just move things back to the top left corner. But we're also going to set the mouse there. Otherwise, it won't. It'll automatically jump back to wherever the mouse is currently located. So locate our mouse to that position, like so. So now when we run this, why don't I just turn that off? All right. No. Oh, we also got to pass in the display. My bad. All right. So now I run this, we move around, press left, and boom, we've automatically snapped back up there. So now let's look at polling the keyboard. Here, instead of doing it the way we used to, we're going to pass in a structure called an Allegro keyboard state, key state, and al get keyboard state. So basically what this is saying is fill this structure with data on what keys are currently pressed. This allows us to handle multiple keys at the same time. And so now we have a structure with the status of all the keys in our keyboard. So let's do a check. So if al key down, and we pass in again our key state structure, and we check to see if the Allegro key right is currently being pressed. So if we're pressing the right arrow, now we're going to do another check. So this is going to show you how you can handle multiple keys at the same time. So if al key down and key state Allegro key CTR LCTR. So if the left control is being pressed, then we're going to move at a greater rate. So x plus equals 10. Otherwise, x plus equals 1. And we shall go ahead and run this code. Oh, no, we won't. I've got errors. I got errors. There we go. So left click, so we're back to our origin, and you'll see I am pressing the right arrow, and we're flying, control, and we are really flying. So there's keyboard handling in Allegro. Very simple stuff, to be honest. The only thing that we've really got left to cover is at the bottom here, make sure that you uninstall your keyboard like so. And since we added the mouse, like so. And that is it for input handling in Allegro. And hopefully that is it for my edit. So if things get a little jarring in the next second, that's because this is the bit I had to replace. So now we move on. Now it's time to move on to audio, which, you know what, I'm going to do last. So I'm going to switch the order up slightly from the Game from Scratch site because my code examples are getting a little confusing at this point. So instead what we're going to do is move on to graphics primitives. Now this is something you're not going to do too often, so I'm only going to skim through it, but this does show some of the additional functionality available in Allegro. Now once again, this is implemented as an add-on, so go into the properties, go to the Allegro add-on section, and switch out and enable primitives to on. Now this is your built-in stuff, things like your, drawing a triangle, drawing a square, etc. So let's take a look at the example. Now once again, if you're following the Game from Scratch, this is example or tutorial 6 as opposed to 5. That's just because the code builds on the other code, and I didn't want to get into that much sloppiness. So now let's go on back up here. So we knitted our image add-on, we started our timer, so let's go right about there, and we will go AL init primitive. Yeah, oops. Probably easier if I add it first. So another header file, another add-on, another header. So Allegro underscore primitives, like so. So AL init primitive add-on, pretty consistent in the way things work here. And next up, we're going to need these for later examples. I'll just go ahead and create them now. This is just a structure of vertices in space for polygons and for lines. So points are going to be used for lines. Polygons are going to be used for, they're just locations in space for drawing later on. You obviously use these coordinates. Once again, 0, 0 is the top left corner, 640, 480 is the bottom right corner. But these are just points in space. We'll use those in a second in our drawing code. And what we're going to do is we're going to get rid of all of the rest of our drawing code in this example. So down here in our drawing code, no display, no background clearing. And I'm just going to show you some of the drawing primitives that are available in Allegro. So first off, we got line drawing, very simple, from a location to a location. So we're going to draw a line to the bottom left-hand corner from the top left-hand corner to the bottom right-hand corner. And AL map RGB. And I'll make this guy red. And is that it? Oh, and then the thickness. We'll do it at 5 pixels for the line. Go ahead and run that. And there you see. Drawing a line is that simple. And the rest of the drawing code works almost identically. We'll just quickly blitz through some of the options available so we can draw. Well, you'll see here, you've got arcs, circles, ellipses, filled ellipses, polygons, filled polygons, triangles. You can get into index primitives. It's basically a list of polygons to draw. Pie slices, polygons, ribbons, etc., etc. So we're only going to show you a couple, and we're going to do this very, very quickly. So a rectangle, for example, we do this 100, 100, 300, 300. So this is a 200 pixel wide rectangle. Map RGB. We'll create this guy in green. 5 pixels as well. All right, what did I miss? Rectang. There's an L in there somewhere. So we run that. And you'll see we now have our rectangle being drawn. Now you'll notice the rectangle is being drawn over top of the line. That is because the draw order is important. So things that are drawn later in the draw call will be drawn over top of things that were drawn earlier. Next up, I will show you spline drawing. A spline is just basically a line from a connection of points, which we declared earlier as points. Spline points. AL map RGB 28 on 28. I don't know what half red, half green is going to give us, but go ahead and run that. And there you see our line with the various different points causing this arc to be drawn off in that, I don't know, baby green, brown color. And you know what, I'm going to stop it there. You've got the idea of what you're dealing with. The drawing primitives are pretty straightforward. You saw some of the more complex ones. There's a couple more examples in the code example on Game from Scratch, but you know, you get the idea of how primitives work. So now let's finally move on to the last topic, and that is handling sound effects in the Allegro library, which once again, I am doing out of order. And I'm doing it out of order because frankly, I am stripping this example down. There's a lot of crap in our code example now, and we don't need most of it. So we'll just go ahead and, yeah, we'll cut down to just about nothing. So we got our Allegro display we're going to be using still. So Allegro sample, so all sound effects are samples. Like so. Allegro sample instance. I will explain in a moment, but we are going to need that variable. Just be aware of it. It should be better here in terms of default memory values. We don't need either of them anymore, but we are going to need audio. Let's go on back to our project. Properties, add-ons. So we don't need the image add-on. We don't need the primitives add-on, but we instead do need the audio add-on, which gives us audio functionality, and we need the codecs add-on, which gives us the ability to load audio files. All right, so now we need to go ahead and include Allegro 5. There we go. So now we have our audio code, gets rid of our ugly little squiggly lines. So next up, we need to tell it how many audio samples we're going to have at a maximum. Again, a sample can be thought of as a sound effect. Not the playing of the sound effect, but the sound effect itself. So if you have a gunshot, you can have multiple gunshots, but that gunshot itself in memory represents a sample. And then the multiple would represent instances, which we're going to use later on. So in this example, we're actually only going to have one sample, and we're going to pre-allocate it. So reserve samples 1. Obviously, in your game, if you had several samples, you would jack that number up a great bit over 1. So now that we have that one sample, we are going to go ahead and load it like so. Is a file called explode.wave. I think I got it from freesound.org. You will notice I copied that earlier on with the other assets. So explode.wave is available right there. Make sure that that is in your working directory, otherwise this will explode later on. Pun not intended. So you should do an assert to make sure that the sample is actually loaded. I'm not going to in this particular case, but and let's do the simplest version that we could possibly do. AL play sample. So now that we got a sample, we can literally play it like that. Now the bunch of these values here, gain is basically your volume, pan is your left versus right, 0 is dead center. So for stereo, playing left or right side. Speed is your playback rate. You can play things at super fast speed or super slow. But if you pass in a value of 1, it will play, okay, where am I at? Speed. All right, so loop is, do you wish to loop the sample or not? So let's go ahead and loop it. So you've got a choice between bidirectional loop and loop once, or play once, sorry. So if you're gonna do a one-off, you do once. If you want the sound to keep repeating itself, you pass in loop. And finally, sample ID we'll ignore for now. Go ahead and run that. It's my bad, and I should have taught this. Remember I told you earlier on, whenever you use an add-on, you need to initialize the add-on before you continue. Yeah, I didn't do that. So I didn't initialize anything, actually. So there's a good example of what happens if you don't do it. So we initialize our main code, we install our audio, we install our, we al init a codec add-on. Now, why the one doesn't use the init add-on and uses install, I don't know. I don't know why they changed their naming convention there. That's a bit of an error in my view. It's one of the only real inconsistencies I've encountered here. But that is pretty much what happened. So I don't really know why. So now I'm going to need some kind of a game loop here because I deleted ours before. So this code is never going to exit. But when it does actually exit, we're going to probably want to do some cleanup. So uninstall audio, like so. Get rid of our display. So uninstall audio, get the display, and again, this is creating a pointer, as you can see up here, so we need to actually go ahead and get rid of it. Destroy sample, type sample. So there's our house cleaning done for now. Yeah, this should in theory run without exploding. There you go. There is the gunshot happening. It's in loop mode, so once it finishes, it should actually play again. There you go. So that is playing a sample in the easiest way. Now, unfortunately, with the easiest way, you have absolutely zero control over it. So it's fire and forget. You can fire it off and have it go. Now, if you want to have a little bit more fine-tuned control over each playing instance, well, that's where this sample instance comes in. We got to do things a little bit differently in that case. So what we do is we get rid of this guy right here. And what we will do instead is create our sample instance. Again, this is a pointer. So al create sample instance. And we create a sample instance from a sample like so. So now that we have that sample instance, we should also, good house cleaning. Get rid of it later on. All right, so there is our sample instance. And now the way we play it is slightly different. So what we need is a mixer. Now don't worry, there's a mixer built in, or you can create your own if you want a lot of fine level detail control over sound effects. Allegro gives you a lot of options, but we're not actually going to get into much detail there. So to play it, attach sample instance to mixer, like so. We pass in the sample instance, and we do al get default mixer. So like I said, it's not too hard because it actually creates a mixer for us. And then finally, now that we've got a sample and the mixer attached for it to play with, we can go ahead and play our sample instance. Now where this comes in handy, oh, I commented out the wrong thing. That's going to cause some confusion. So where this is handy now that we're using a sample instance as opposed to a sample itself is we have more fine-tuned control over it. So what we're going to do now is have our code exit when the sample is over. So al get sample instance. So you see we've got the different function calls so we can get values from that instance. So we can see how loud it is. We can see how much time is left playing, if it is currently playing, the speed it's playing at. We've also got corresponding set functions, so you can change those things on the fly. So that's why you would use an instance over a raw sample. So we're going to check here just to see if it is playing. And while it is playing, our code will continue to execute. Otherwise, as soon as it is no longer playing, this will evaluate to false, and our game will exit. So let's go ahead and run that. And find my build errors. All right, what's your issue? Oh, I never created a display. Oops. Didn't technically create a window for this example, so we don't need a display. Okay, let's go ahead and run that. There you go. Place the sample, and there's a bit of silence at the end of the sample. Gets to the end, and we exit. Now, why am I getting an exception on destroying the sample? I almost guarantee you it's an order of operations thing. Probably shouldn't destroy the underlying audio system and then make audio calls. So it basically don't get rid of something while you're still using it is the underlying lesson of the day. And that's it. That is, again, very top level. It's 40 minutes of coverage, but we really did cover quite a bit there. We covered, setting up your window, setting up a game loop, setting up timers, event queues, handling the mouse, handling the keyboard, handling sound effects, really all of the basics and graphics primitives, the basics you need to create a game. Now, obviously, you can go into a whole lot more detail, and you would need to create a game, but all of the building blocks are there. Like, everything you need to know to get started is available in this particular tutorial or the text version, which, again, will be linked down below. And again, this is the Allegro library, very low level, consistent in its approach, a bit wordy compared to some. It doesn't hold your hand quite as much as some frameworks, but some people are going to love that. Some people are definitely going to hate that. Kind of goes either way, but I hope you did enjoy that. Coincidentally, I never mentioned this up front, but if you're a patron backer, the entire project used to create this, including all the assets, is now up on Patreon and in the Patreon Dropbox. So if you want to not type anything, it is available for you there. And for everyone else, all of the source code is up on Game from Scratch. You're going to have to provide your own sound effects, but that's about the extent of it. I hope you found that useful. If you did, please, of course, do click that like button. And so again, I'm not going to be doing a series on this one. This is going to be a one and done. But I hope you did find Allegro interesting. This is a library I had it got me started way, way, way back. Back in the days before any of these things existed. There was no SFML. There was no SDL. There was almost no open source. And there was this wonderful graphics framework. And so many developers owe their start to this thing. So I felt, a bit of a nostalgic trip down memory lane to do a bit of a series on it. But I hope you did find Allegro interesting. And if you're into game development stuff, we got all kinds of stuff on this channel, so if you haven't already, do consider hitting that subscribe button. And if you really like this channel, I really do appreciate it if you back me up on Patreon. Of course, just being here is a great help. So again, I thank you all. I hope you found this useful. I hope you enjoyed it, and I will see you all next video. Cheerio.